Hello, how are you? So the third topic for today is uh, difference between scalar and vector quantities. This is like a basic topic of physics, so we have left some topics before. So I think that we should cover them one by one now before moving on to further into electricity and electromagnetism details. So, getting right on to the topic now. So, what is a difference between the scalar and the vector quantities? For example, let me write some of the scalar quantities here. Time is a scalar quantity. Uh, Mass is a scalar quantity. Speed, distance. These are examples of scalar quantities, and the examples for vector quantities are force, velocity, acceleration, momentum, etc. So the major difference between a scalar and a vector quantity is that in a scalar quantity, only the magnitude is required, but in the vector quantities, magnitude plus uh, direction is also required. So you can write the magnitude, magnitude plus direction, and in scalar only magnitude is required. Only magnitude. So what does that mean? It means that in a scalar quantity, we do not need to know whether like the time has only one direction, like time moves on only. There is no direction for mass, like we cannot say 3 kilograms in the east or 3 kilograms in the west. So mass has no direction. Same like that, we cannot say there is a distance of he covered a 3 meter distance towards any direction, because distance and there is a different quantity that is known as displacement. We can say that he covered a displacement in that direction, but in a distance direction is not important and not given because it is a scalar quantity. I will show you the difference between these two. For example, if there is a person, he covered uh, this distance. So he went from position A to position B and then to position C. So the distance between A and B is 5 kilometers and B and C is 3 kilometers. So so that person basically covered a distance of, he started from this point and he reached at the B, and from B he came back at the C position here. So he basically covered a distance of 5 plus 3, 8 meters. So distance in this case is 8 kilometers. But the displacement he covered is just 2 kilometers. What does that mean? 2 kilometers in the right direction. What does that mean? It means that for distance, as the direction was not important, so he went at the right direction first and covered a distance of 5 kilometers, and then he came back and covered a distance of 3 kilometers more in the left direction. But effectively, he just covered this distance this much. So the effective distance he covered was this much, and that is equal to 2 kilometers. This distance is 2 kilometers. So effectively, he covered 2 kilometers in the right direction, but for distance, the direction is not important. So we can say that he covered a distance of 8 kilometers and displacement of 2 kilometers in the right direction. Same like that, we cannot specify a direction for time, mass, speed, and distance. Like we cannot say that a car is moving with a speed of 40 kilometers per hour in the upward direction. So that would be, if direction is specified, so that would be velocity. We let's state or work with another example. There is a ball, and if we want the ball to move, we can apply a force. But to apply a force, we have to specify some direction. We can apply a force in this direction. We can apply force in this direction or this direction. So in this case, we can say that we applied a force of 5 newtons in the in the east direction or on the right side, or we applied a 2 Newton force from the upside, or we applied a 10 Newton force at an angle of 45 degrees. So to specify force, we have to provide some direction also. Same like that, we can the velocity and accelerations. Acceleration is a vector quantity, and momentum is also a vector quantity. So uh, in all of these, the magnitude plus direction is necessary to completely define these properties. To summarize or to sum up, I would share another example. For example, car is moving. A car can move with a velocity of 40 kilometer per hour, and a speed of 40 kilometer per hour also, at a constant speed. Like the speed won't be changing. This number won't be changing in both cases. But for velocity, we have to specify a direction also. So a car can be moving with a velocity of 40 kilometers per hour and a speed of 40 kilometers per hour also. But in this case, the acceleration will always be equal to zero if it is moving with a constant speed. But this can be or cannot be equal to. So it is not necessary that it will be always equal to zero if velocity is 40 kilometers per hour. It can move uh, in this path, like in a circle, and the velocity, if velocity is 40 kilometers per hour. So as this direction is always changing, because in this spot it will be moving in this direction, in this spot it will be moving in this direction, in this spot it will be moving in this direction. But as velocity is direction dependent, so in this case even the velocity has a constant magnitude but the direction is constantly being changed, so acceleration would not be equal to zero. So this is a basic difference between a scalar and a vector quantity. We will talk about the scalars and the vectors in the next lecture in detail. So see you tomorrow. See you in the next lecture.